So far, we've been solving problems that are fairly straightforward and that they give you the percent that you should use. But often when we're talking about percents, something will be a percent more than or a percent less than some value, or a percent off, which you'll often find with shopping. And we want to figure out exactly what is that original value. So what you're going to want to do is, if it's a percent more than an initial value, you're going to add that P to 100. And you can use these formulas to find the final value or initial value. You can also set up a proportion as we were doing before. So I'll show you both ways. If the final value is less than the initial value, then we're going to be doing 100 minus P. So that's like if it's some percent off. For example, if Best Buy is having a sale and they're offering 40% off some items, we've been wanting a Roomba iRobot to clean for us. It's normally $350. So we want to figure out, well, what's the sale price if it's 40% off? So since it's 40% off, that means I'm going to be paying 100 minus 40, which is 60% of the original value. So if I want to find out what is my new cost of the Roomba, I can use this formula because I have the initial value. I have the starting cost of the Roomba. I want to figure out the final value, what I'm going to pay, what the sale price is. Now, I didn't do 100 plus P because it's a percent off. So I used the 100 minus P. So I can do 60% times my initial value, which is $350. Now I don't put 60% in my calculator. I put 0.6 or 0.60 times 350. And I get my sale price is $210. Now, if you feel like it's another formula to memorize, I don't want to do that. You can still use the proportion. You cannot put 40% in there because it's 40% off. So step one is to get the correct percent, which is the 60%. So once you get the 60%, we still set it up the same way, 60 over 100. The part, well, we're looking for the part, right? The whole price is $350. We're looking for the sale price. It better be less than $350, because if it's on sale and I'm paying more, then something is wrong. That's not a good deal. Now I cross multiply. 60 times 350 equals 100x. 60 times 350 is 21,000 equals 100x. Divide each side by 100, and I get the exact same answer, $210. So this is almost a little bit more work, but I don't want you to feel like there's more and more formulas that you have to memorize. You can keep setting it up as a proportion if you have gotten comfortable with that technique. What would the total bill be after the discount and a 6% sales tax? So if we have a 6% sales tax, that gets added on. It's not 6% off. I have to pay 6% more. So 6% more than 100 is 106%. So if I have 106%, I can do 106% times the $210, because we said that was what the sales price is, the sale price. And 106% as a decimal is 1.06. 1.06 times 210 is $22. Oops, $222. If it was $22, that would be really interesting considering it was on sale for $210 and somehow my tax made it cheaper. So keep in mind when you're writing your answers, they should make sense. $222.60. Of course, if I messed up the other way and I said it was like $2,000, that should also be a red flag because I shouldn't have sales tax that takes me from a $210 Roomba to a $2,000 Roomba. Again, if you're like, I don't want to have to do anything different, you can set it up as a proportion. The key here is, again, you can't just put 6% in. Because it's the 6% sales tax, we're adding on the 6%. So you would have to put 106 in my proportion. I'm trying to figure out how much the new price is going to be. So I'm trying to figure out when I pay the 106%, what my new price will be. So X is going to go next to the 106, and my sale price of $210 is going to go in the denominator. If I cross multiply, 210 times 106 equals 100x. 210 times 106 is 22,260. If I divide by 100, I can just move the decimal over 2. And look, I get the exact same answer. Example 6, you receive a 5% pay raise at your job, and you now earn $17.25 per hour. How much did you make before the raise? So a 5% pay raise means that I am now making 100 plus 5%. So I'm making 105% of what I initially was making. So I'm going to use the second formula up there. My final value, what I'm making now, is $17.25. Divided by 100 plus P, which we already found was 105%. 105%. I need to change that to be a decimal. So 1.05, 17.25 divided by 1.05. And I get that I was previously making 16.428. So of course we always round money to the nearest hundredth because that's just what makes sense. We go to the nearest penny, and the nearest penny would be the nearest hundredth. Since this is an 8, my 2 is going to go up to a 3. So $16.43 an hour was what I was making before. Again, if you want to set up a proportion, that is totally fine. We're going to have 105% over 100. Now, the $17.25 per hour, that is after the raise. So that should go next to 105. And I'm trying to figure out what I was making before, what I was making when I was making 100% of my salary, not 105% of my salary. So this one, it doesn't totally follow the part and whole idea, but I just want you to notice that the 105% has to go with the new salary. 100% has to go with the old salary. They go next to each other. Then I cross multiply. 1725 times 100 equals 105x. Move the decimal 2 places. I get 1,725. Divide by 105. And I hopefully get the same thing I got before. I do. I get that x is 1643. How much was your raise? I almost missed that question. It's like sneakily down there. So your raise was $17.25 minus $16.43. $17.25 minus $16.43. I got an 82-cent raise. Before we do example 7, I just want to comment on a small mistake I made earlier up here. I said that it didn't really matter if I put the percent symbol or not. I really should not have it there because then I'm saying 110% in here, which would be 110 divided by 100, and then I'm dividing by 100 again. That doesn't really make any sense. So when we do put the percent in there, let's go ahead and not put the actual percent symbol, because by expressing it as 110 over 100, I'm already essentially putting here that this is 110%. So let's go down to example 7. An item is on sale for 15% off and priced at $60. Find the original price. So if it's 15% off, then I am paying 100 minus 15, which is 85% of the original price. So now I'm going to be using this formula to find the original price. The final value, which is the sale price, divided by that 85%. Again, since it's percent off, I'm doing 100 minus 15 instead of 100 plus 15. So I've got 60 divided by 85%, but 85% I write as a decimal. 60 divided by 0.85, which is 60 divided by 0.85, 70.588. Since this number is greater than 5, the first 8 is going to go up. So 70.59 is the original price. Do a little sanity check. My original price should be higher than my sale price. It is. My sale price is $60. But if I got something that was crazy off, 15% off isn't a great sale, depending on what it is. But if I got it like, oh, the original price was $300, I'd be like, that seems kind of crazy. If I got it that the original price was less than $60, that seems kind of crazy. So just check your work, make sure it makes sense. If you prefer to set it up as a proportion, your proportion would have been the 85 over 100 equal to, well, the 85% goes with the 60 because that's the sale price, and we're trying to find the original price. I'm going to go ahead and let you work that one out if that's the way you want to approach it. But I just want to show you again that you can do the proportions for all of them. So if your bill at a restaurant is $234.60, I hope you had a really phenomenal dinner, and you want to leave a 20% tip. So if I want to leave a 20% tip, that means that I'm paying 100 plus 20. So I will be paying 120% of the original bill. So that's my initial value. I want to find the final value. So I'm going to be using this formula. So I'm going to do 120% times the initial value. The initial value is 234.60. Again, I wrote 120%. I need to convert that to a decimal. So that is 1.2 times 234.60. 1.2 times 234.60 gives me a final bill of $281.52. Hopefully at this point you're noticing that when I'm going to put things on my calculator, I am never putting the percent. I always have to convert the percent into a decimal before I put it in my calculator. The exception here is when I'm writing it in the proportion, I'm not converting this 85 into 0.85 because I already have written it over 100. So if you're really thrown off by when am I using the percent and when am I changing it, moving the decimal and making it into a decimal, I would stick with the proportion method because essentially it's already done here for you. Because we said that percent means divide by 100. So instead of writing 85%, I'm writing 85 over 100, which is 85%. Hopefully providing you two different techniques is not thoroughly confusing you. I'm just trying to offer you the best way for you to solve the problem. If you wanted to do this one with a proportion, oops, and I accidentally messed that one up a little bit. How much tip would you leave? I did, what is your total bill? How much tip would you leave would just be the 20% of the 234.60. And again, I need to convert that to a decimal. So I'll just rewrite it since I'm kind of running tight on space here. We've got 2 times 234.60. And I get that I'm leaving a tip of $46.92. So then I've already solved how much my total bill will be. I could have also, if I had actually read what the question said, since I found the tip, I could have just added it to the 234.60 instead of taking 120% of the original bill. I could have added it, and I should get the exact same thing, and I do. I get $281.52. If I wanted to do this one as a proportion, for part A, how much tip would you leave? To do that, I'm only finding the 20%, so I'm just putting 20 over 100 is how much out of the entire bill. So this would be my proportion. Again, if you prefer to solve it with a proportion, I'm going to let you do that on your own. For the second part, the proportion would be extremely similar, except to find the total bill, I would change that 20 into 120. Again, the X is going to be up there because I'm trying to find what 120% of my original bill is. Example 9. Your receipt shows that you paid $19.26 for a phone case, tax included. The local sales tax rate is 7%. What was the pre-tax price of the case? So we're trying to find the initial value. We're given the final value. And we have that the tax rate is 7%. Well, I know that the tax rate is added on, so I'm paying 107% of the original. So to find my initial value, I'm going to take so 100 plus 7 is 107%. I'm going to take the 1926, divide by 107%, which is 1.07. And I get that my pre-tax price was $18. If you wanted to set this one up as a proportion, I would have, let me see where I can squeeze it in here. Let me move some of this over a little bit. I would have the 107% over 100. Well, the price that I paid, that was including the tax. So since that includes the tax, that should go next to the 107. So this is what I would use if I prefer to set up a proportion and cross multiply. Example 10, your company has hit hard times and needs to make budget cuts until they can complete a merger with another company, which should fix the financial issues. You're currently earning $65K, not bad. You've been a loyal employee for 15 years, and your boss does not want to have to let you go. As a way to make sure he can keep his best employees, he comes up with the following compromise. He asks, would you be willing to hang in there for 1 year for the merger to take place and finances to improve and take a 10% pay cut as long as he promises to give you a 10% pay increase after 1 year to get you back to your normal base salary? In fact, he says he wants to show you your appreciation, even though you're losing money, for the first year, and he's going to give you a 10.5% pay increase. So if we want to figure out what's going to be our current salary with a 10% pay cut. So if I'm getting a pay cut, that means I'm getting 100 minus 10. I'm going to end up with 90% of my original salary. So I'm going back up here to my formulas. I say I want to find the final value. So I'm going to do the 90% times my initial salary. So 90% times 65,000, which is 0.9 times 65,000. And I get that I'm going to be making $58,500 for that year. If you wanted to set up a proportion, I would have 90 over 100 equal to, well, I'm looking for what the 90% salary is, what the decreased salary is. My current salary is $65,000. That's my 100% salary. 1 year later, I'm going to add the 10% back. Well, you are going to be so tempted to be like, well, we're adding 10% back, so that gets us to the original salary, which is literally what your boss said. But we're adding 10% of the new salary. So we're going to end up with 100 plus 10, which is 110% of the 58,500. So 110% times 58,500 is 1.10 or 1.1 times 58,500. And I am getting 64,350. Now that's not good. I'm not back to my original salary. So if I wanted to set this up as a proportion, I have 110%. My 100% salary is now 58,500. I know in the previous step, I had a different 100% salary, but that's because that's what I was starting with. I was starting with 65,000. Now I'm at a new place in my life. I'm starting with less money. So that goes next to the 100. I'm trying to figure out what the 110% of the 58,500 is. So let's say instead we add 10.5% back. So 100% plus 10.5% is 110.5%. 110.5% of 58,500 is and I accidentally typed in 110.5. Remember to be careful there. I need to convert that to a decimal. 1.105 times 58,500, you get a really crazy answer where you're like, absolutely, I would take that salary, but that's not the correct answer. I get that I am now going to make $64,642.50. And if you wanted to set it up as a proportion, it would be identical to this, but you would have 110.5 right here. So the bottom line is it's not a good deal. You're going to have to find a new job unless you are going to be okay with just not making that $65,000 again. Example 11. And there's a conclusion there, which I said, not good. We can say, quit your job. Example 11, your favorite store is having a big sale. An item you want at the store regularly priced at $100 is on sale for 35% off. So if it is 35% off, then you are going to pay 100 minus 35, which would be 65%. You will be paying 65% on the original item. But now, because you're a faithful customer, the store is also giving you an extra 25% off. So 100 minus 25 is 75% of the price that was already discounted. So it says, what percent was the item discounted by? Is the item 60% off? Is the item 30% off? 60% would have just come from if you had added the two numbers. That is incorrect. 30% would be the average of the two numbers. That is also not how you find the total percent off. So we know that we're paying initially 65%, but then we're paying 75% of the 65%. What we're going to do is we're going to multiply them together. And of course, I don't put percents in my calculator. .65 times 0.75 gives me 0.4875. So 48.75% of the original price is what I am going to pay. But it didn't ask me what percent of the original price. It asked me what percent off. What percent was the item discounted by? So it would be discounted by 100 minus 48.75, which is 51.25% off. You don't have to use the $100 to solve this problem because we can figure out what percent off it is no matter what the price, and there will be questions you're asked where they don't give you the original price. If you wanted to set up a proportion, it's probably going to be more work because you're going to have to do it twice. But you would just figure out, you would have the 65% off was the initial one. And we are looking for the 65% off price, given that the original item was 100. Well, hopefully you don't need to cross multiply to figure this one out, because if I've got x over 100 equals 65 over 100, that means x has to be 65. So I am now paying $65, but I'm getting an additional 25% off. So I'm paying now 75%. So what am I paying if I was going to pay $65 with the initial discount? Now I'm going to have to cross multiply because it's not a super easy problem. So I've got 65 times 75 equals 100x. 65 times 75 is 4,875 equals 100x. Divide by the 100. I get that I am paying $48.75, but my original item was $100. I want to know what percent it was discounted by. So $100 minus $48.75 gives me that I'm getting the $100 item for $51.25 off. Since my item started at $100, it's the same as saying that it's 51.25% off. Because it's $100, it's easy to work with it that way. So hopefully that made sense. Example 12, a store advertises that it will take 150% off the price of all merchandise. What should happen when you go to the checkout to buy a $500 item? So if it's 150% off, that means we should be paying 100 minus 150, or negative 50%. So if I want to use one of these two, I want to find the final value. I'm given the initial value of 500. I did the 100 minus P because it was percent off. So I'm going to do negative 50% times 500, which is negative 0.5 times 500, which gives me negative 250. So that means when I go to the checkout to buy a $500 item, they should pay me $250, which of course makes no sense. So they're either have no idea what they're doing or they're just giving away money. If you wanted to set this one up as a proportion, we would have the 150% off. Again, we don't put 150 in the proportion then. We have to subtract it from 100. We have negative 50 over 100 equals 500 is the 100% price. We're looking for the negative 50 price. So X goes next to the negative 50. So some things that people will do incorrectly with percents, abuses of percents. Sometimes there are shifting reference values. So a 10% pay cut is followed by a 10% pay raise. We looked at that example. It's not the same as just coming back to the original because 10% of the salary of the original salary is going to be different than 10% of the reduced salary. Less than nothing, decrease calorie intake by 150% to lose weight. So that's, again, kind of like we were looking at the 150% off of the merchandise. Don't average your percents. So if 70% of the boys and 60% of the girls in the class vote to go to the water park, then 65% of the students in the class voted to go to the water park. That is not how you deal with percents. We can't just take the average of the two numbers.